Hey, alright, look at that. We're live. Where the hell is my phone charger? I'm tired. I don't really feel that well. And I've got a lot of homework to do. It's gonna be a long night. How's everyone doing? Let's get some psychedelic guitar music going, as a guy likes to put it. Hold on. Where is... Oh, we'll sign the one note, and then where's 10-hour Dwarf Fortress song? Hell yeah, dude. Alright. Two-factor authentication. Timed out. Well. come on. There we go. Yes, this is my device. Are we good? I think we're good. Alright. Yo, how you doing, Noemi? Oh, I don't feel good. And I got a lot of homework to do, so it's gonna be a long night. Other than that, I'm doing well. How about you? Ah, fuck, let's just keep working on Heat Transfer. I gotta get a little more done this weekend than nothing. We'll start on the Wily. I'll share my screen here in a second. That music is loud, actually. No, we're at normal volume. Yeah, there we go. Doing okay, I guess? Well, you know, sometimes it's all you can ask for. You know, if there's one thing that my 23 years on this planet has taught me, is that things can always get worse. Which is a very negative thing to say, but it's true. I don't really have a way of reading chat, I don't think. This is going to be kind of a nightmare. Maybe I can pull it up on my phone. Yeah, that's not going to be fucked. Yeah, I'll pull this up on my phone. Boom. Alright, there we go. Start assignment. Oh shit, I don't want to do this right now. I like to take weekends off of doing this, but I've just got so much to do, and I have not done nearly as much as I should have this weekend. Like not even close, not even a little. But you know what? That's fine. Where's my damn stream? There we go. Of what I heard on Saturday? Oh yeah, forgot about that. I hope I'm thinking of the right thing. Pretty sure I am. Was that last week? It might have been last week. My sense of time's completely fucked. But deaths are never. If I am thinking the right thing, deaths are never simple to grapple with, or well, hardly ever. Where the hell does this end? Alright, Wily only has 2 problems. Oh. Oh, good. That's fine. Just gotta drink more water. Number 1. Alright, an opaque horizontal plate has a thickness of L? Why are you... Alright, I'm not gonna question why you're labeling thickness as an L, which is typically length. But you know what? It's just one of those days. .21 whole millimeters. Okie dokie. Oh, it's got a K of 25. I am sharing my screen, right? Yeah, we're good. Okay. Was that watts per meter Kelvin? Water flows along the bottom? Okay. We're moving this up then. There we go. Go up. Okay. Whoops, that's not the right tool. The fuck? That's fine. Alright. Yeah, there's no way this goes well, but I could bring up my homework on, or the thing that I'm writing on this F. Pulling holes in the tires? Damn. I love conflict, am I right or am I right? I don't like, no, we're just gonna say T infinity water. So what was that? 25C? Yeah. And then we have, we'll do that, and then we'll do like, no, we won't do that, we'll just do T infinity, was this air, presumably? Yeah, air is 260, god damn, degrees Celsius, with a convection coefficient of 40? What did it say on the assignment? Sure. I'm going to assume this is number 1. Yeah, problem number 1 and problem 2. Right, the bottom of the plate. Yeah, no shit. Okay, that's not helpful. Oh, that is HA. Yeah, okay. I guess we just don't have HW. T top, T bottom. I'd offer some, or attempt to offer some kind of solace, but I feel like anything I would say would be kind of moot, just simply based on the fact that nothing like that's ever really happened to me before. And I feel like anything I would say wouldn't be overly constructive. 2 degrees Celsius. Isn't it opaque? 0. The fuck? I don't. What the hell? Alright, first things first, draw an energy balance. Yes, good lord. Does it say opaque? And it does say opaque, okay. Tau equals 0 because opaque. Alright, energy balance time. Can I? Why is this? Come on, OneNote. Well, I guess we'll just have to deal with this. For some reason, I can't scroll further right. Yeah, energy balance. Alright, so we'll have... Let's change colors to orange. And so black, we'll do light blue. There we go. Alright, so we'll have some Q convection of the water going out, presumably. Yes. And then we'll have some Q convection. I'm not drawing that right. Q convection of the air going in. Because the air is really, really hot. We'll have some kind of... I'm moving this somewhere else. Alright. Then we'll have some kind of G coming in. G absorbed. Which is just going to be alpha G. Then we'll have some kind of G reflected. Which will be rho G. And then we'll have some kind of emission going on. E, which will be epsilon sigma t to the 4, or probably t top, right? Yeah, t top to the 4. There we go. Oh, we do have G, okay. Oh, we have the amount reflected as well. Alright, so let's go back to base colors. Then we'll have G reflected. Can I scoot over more now? A little bit. I'm going to do this. Just make a mark way over here. And then wait for it to update. So G reflected is going to be equal to rho times G. And we know the number of G reflected, which is 435, is equal to rho times 1450. You'd use it to counter the trigonometry, damn it. How you doing, Mr. Sid? I really should. But I'm more of I've never been one for meta plays, so I'm more of an energy balance kind of a guy right now. But maybe we might try Pythagoras against trigonometry. Just if we're feeling a little spicy, we want to go pub stomping a little. Oh, can I scoot over now? Oh, I can. Look at that. Can I zoom out? Oh, there we go. Look at, boom, we're making progress. Alright, so rho, whoa. So rho is going to be 435 over 1450. Quick, type in chat now what you think the answer is. Then I'll calculate it myself, and then I'll give you the right answer. We'll see, we'll be learning together. What divided by 1450? Rho is a very strangely even number of 0.3. Alright, nice and respectable 0.3. Which means the absorptivity is 0.7. Oh boy. Radiosity. Uh-oh. Okay, we'll box that as an answer. Then we'll do alpha plus rho plus tau equals 1, which will boil down to alpha is equal to 1 minus rho, so that'll equal 1 minus 0.3, so alpha equals 0.7. That is a unitless quantity since it is a fraction. It's like a ratio. That's my guess. You know, bad guess, but I appreciate where your mind's at. I also didn't know you could type infinity symbols into the YouTube chat. How'd you do that? Did you go online and like copy the thing, or did you use like Windows key combinations or whatever those are? Alright, emissivity. Honestly, I don't know. Is it gray? Probably not. This is not a good assumption to be making. What was the... Oh, that's right, this was extremely unhelpful. Alright, well, before we go any further, we'll try these. Yeah, I didn't think that was going to be right. It was worth a shot, though. We don't know if the source is a black body, though. Control C, Control V. Yeah, that's fair. That's kind of what I figured you did. Oh, radiosity is what's being emitted. I think I can answer that, can't I? Oh, no, because I don't know E. E. I mean, I can find G absorbed. I don't think that really helps me, though. Well, it will help me, eventually. I need to find epsilon first, though, and I don't know how. It's not a gray surface. I didn't think it was, but we ruled that out. Radiosity is something we can find once we find epsilon. Once we find epsilon, basically epsilon's the only thing holding us back. Wait, can we just do... know, we can do that to get alpha. Big surprise there. How do we get... Guess we could do that. But we don't know the total E, though. These aren't the right notes. I can probably rationalize... No, well, we know that's true because the surface is diffuse. So we know that the spectral emissivity and the spectral absorptivity equals each other, but we don't know what the spectral absorptivity is because it doesn't tell us. And it's not gray. The stupid heart message is in the way. What is that expression? Oh god, bro, what the hell? Hey, you want to know what that derivative is? Here, I got you. You know what we're gonna do? X to the power of 4. I could actually do that, I'm pretty sure. I assume that's what you mean, not 4x plus 3x to the power of 2 plus some constant 8 quantity times the cosine of x by dx. Wow, that's pretty great. Gotta love the product rule, man. There you go. There's your derivative. It's the negative x to the 4th times the sine of x minus 3x squared times the sine of x plus 4x to the power of 3 times the cosine of x plus 8x cosine of x minus 8 sine x. There you go. I figured that's what you meant, though. I assume you meant to the power of, not just 4x. I think I know what you mean. I don't know, you can tell me if I got it right. Final answer. Alright, But if you're wondering if I could have done that by hand, the answer is yes, it would have just taken me a while. Multivariable calculus? It's not that bad. It's like doing it by hand, though. Doing it by hand is just the worst. I'm kind of stumped, actually. It's because I don't have this spectral... I guess I could assume... Could I assume that? Maybe. Alright, let's go here to useful tables. You know what's pretty great is I could probably get copyright strikes by my university for showing all this. Because I'm technically showing them like proprietary knowledge to the internet. But it's like, who cares? No one's gonna copy this question from Wiley. I guess no, because if I were to show like the Canvas homework, then the school could get me. But no, Wiley could get me for doing this. Oh, but I don't have a... Shit. Never mind. It doesn't work. I can't use those tables because I don't have a... Damn, dude. I might have to come back to this one. Or just ask in office hours tomorrow. Let's see this. This I can do. DT. Uh-oh. Alright, well, we'll get there when we get there. Let's leave a bunch of space. Homework. Number 7. Oh, come on. There we go. Hoy vey. 10mm thick workpiece. Initially at 25°C is annealed at a temperature of 725 for a period of 5 minutes. Oh jeez, this one's gonna suck. Suck. Alright, what is it? It's 10mm thick. T1 is 25°C. T2 is 725°C. Time period is 5 minutes. Which is equal, that's 5 times 60, that's, what was that, 30? No, that's 240 seconds, right? Did I do that right? 60 times 5? I was right the first time, 300? Oh, it's 40. I was thinking 8 times 5 was 30. Yeah, 30, but 8 times 5 is 40. So it's 300 seconds. So T infinity is... that's 750°C. With a convection coefficient H of 100 watts per meters Kelvin. There's people laughing outside my apartment. How dare they have fun? And we're given a bunch of thermophysical properties. I'll write all these down. Rho as in density is 2,700 kilograms per meters cubed. Is that C as in specific heat capacity? Not C as in the speed of light or the speed of sound or any of the other 800 variables named C per kilogram Kelvin. It's never a fun day when you're given that. And then we're given K is 165. Oh, it's meters. Where is it? Meters squared Kelvin, and this one is meters Kelvin. Then we're given a graph. Graph like this, where we've got epsilon 1 starts low, then it goes high. Alright. This is 0.3. This is 0.9. And the discontinuity is at 2.5 with is it micrometers? Maybe? I forget what mu is. Epsilon of lambda. Alright. Is opaque and diffuse, good to know. So epsilon is going to equal 0.3 times the fraction of black body radiation from 0 to 2.5 plus 0.9 times the fraction of black body radiation, or times 1 minus the fraction of black body radiation from 0 to 2.5. I'm going to assume the working. Oh no, it literally says what temperature we're at. So lambda t is going to equal 25 times 2.5. What's that? 50 something? 70? About 70? It's gonna be 63. Hey, let's go. 62.5. 62.5. Wow, that's a really small number. Oh, because this needs to be in Kelvin. Whoops, that's not right. 25 plus 273 times 2.5. So that's 25 plus 273 times 2.5. 745. That's still a kind of a strange number. Doesn't make me feel nice and warm and fuzzy. 745. Literally 0. It's gonna be fucking 0, dude. Look at that. It's like halfway between actual 0 and 0.000016. Are you kidding me? What the fuck? Me when that number is actually 0. This is just gonna be 0.9. I could just put in 0.9 as the answer, and it's just gonna be, hey, you did it. With rounding error, probably. Is it johndcook.com/interpolator? 600, 0, 745. There you go. Woohoo! So the fraction from 0 to 2.5 at, what's that, 2 plus 2, that's 293 Kelvin. 293 Kelvin is a whopping, resounding 0, basically. This isn't even worth doing. This is literally not worth doing. This is rounding error. worth of stuff. This does not feel right. I don't think... That doesn't feel right. I'm pretty sure it's right, though. That's just mad small. .9 times 1 minus 0 is 0. It's going to be, what's that? That's 9 point, it's going to be 0.999988. 0.3 times 0.0000116 plus 0.9 times 1 minus 0.0000116. Yep, yeah, basically. Uh, 899. It's just 0.9. It rounds up to 0.9 unless I go out 7 decimal places, basically. 0.9. That's not right. That can't be right, dude. That's just so unreasonable. Well, at least the alpha will be a little different. Whoa. Don't glitch out on me now. Alpha is going to be 0.3 times the fraction from 0 to 2.5, but it's a different fraction this time, plus 0.9 times the fraction from 0 to 2.5. And this lambda t is going to be 750 plus 273, so it's actually going to be a sizable number this time, times 2.5. That is 2557.5. So the fraction from 0 to 2.5 of... This is wrong. This is a function of 745. There we go. This is a function of 2557.5. Okay. So this will be 2000 plus 2898. Oh no, it's 2. Yeah. No, it'll be 2400. Where do you go? Whoa. I'm sorry. What? Okay. That's fine. Ignore the problems. 400 times... Remember, that isn't 0. Times 2557.5. This will be 2600. And this is going to be 0.183120. 0.17401113, and then 3 nines. 999. Alright. This is going to be a little more reasonable. I'm gonna get both these wrong, you just watch. 0.3 times 1, 0.1740113999, 0.9. That's not right. times, let's go off a number. Yeah, that's a little more reasonable. That is 0.7955931601. Alright, let's try it. 0.79. How many decimals you want? I'll do 3. They're both right. Okay, cool. So this is alpha equals this. I just realized you guys are still staring at John D. Cook. Let him cook. I didn't actually write that answer down. Epsilon is 0.9. Alright. Oh boy. Man, I just do not feel good right now. Oh. QNet in. We don't have a... Hold on, there's notes on the assignment page. Maybe those will help us out. I might just stop, honestly, just stop right here. I've done about half of the heat transfer homework at this point. There's so much else I need to do, but I just do not feel good. Suspended in the air, that's not really helpful. I mean, it is actually helpful. Were we given a length? I don't think we were given a length. We were just given a thickness. Yeah, cool. I don't need that. I mean, I guess I don't, but it would have been nice to have. Guess we assume it cancels out, it'll just... I can set it to 1 and it'll work itself out. Alright, energy balance time. Alright, so it's taking in some kind of G absorbed. It's... I think we're assuming it's... Do we need to worry about reflectivity? Probably. Probably not, actually. Gotta make it a squiggly line. T initial. We put it as T initial. T in it. And then it's convecting outwards. No, it's convecting inwards. QNet in? In specifically. So I think we just need G absorbed times... That's a double prime anyway. can probably find that. I'm not giving it G though. Ooh. That complicates things. Q convection in, but there isn't a convection out, so I won't specify that. And there's going to be some E storage term. So it's E dot, that's an epsilon. E dot store plus E dot in minus E dot out equals 0. Pretty sure that's the sign convention. Let's just double check. I think it's in conduction. No, it'll be in heat diffusion. Come on. You can do this. Don't load lump capacitance. Just want to know what the sign convention is. That's not a full energy balance. Well, I'm pretty sure I have the sign convention right. Yeah. Yes, but also no. If we take away the equal or that plus and make it an equal sign, now it's the right sign convention. And then this is MCP dt is equal to G absorbed plus Q convection minus E out. Look, this is heat transfer, my sir. How you doing? Alright, we'll go back here. So this is going to be alpha G plus, oh god, what is the heat transfer or convection equation? I don't remember. Types of heat transfer, go! It is H delta T, okay. H times Ts minus T infinity. I feel scammed. Why do you feel scammed? We're game at it? Bro, this isn't... Did you... No one ever reads the title of these things. It's literally called Homework Stream. Alright, buddy? We might be playing game in a second. I don't really feel... I might just be getting off in a second. I don't really feel that good right now. So this is going to be epsilon sigma T S to 4. Probably... I still don't know what G is, though. That's the problem here, man. I don't have a G. I could find it. Maybe. How would I find it? I could do sigma, but we don't have a... I guess if we assume the walls are black bodies, and we... Yeah, if we assume the walls are black bodies, we can find G. G is going to be sigma T source to the 4th, which is going to be 5.67 e to the negative 8 times 750. Oh, this is being calculated actually. Plus 750 plus 273 power of 4. That equals something. 5.67 e to the negative 8 times 750 plus 273 to the power 4. That is certainly a number. 62099.14. What is this? Watts per meter squared, I think? Yeah, watts per meter squared. I'm going to assume it's watts per meter squared. Because I don't know what the units of sigma are. That's fine. It literally says. Yeah, it's watts per meter squared. Okay. So we'll have Q double prime net in? Net? Including losses? Isn't this whole thing then? Fucking probably. I don't know. No, I'm not on the right side. Okay. So this is going to be 0.796 times 62099.14 plus whatever that H is. What was the H? 100. It's 100 times 25 minus T infinity. So it should be negative plus, because those two should add together. God, I don't remember, man. We're gonna say I think they're both negative. Negative, positive. No, but they can't both be negative, because then they won't be the same sign again. Minus 750 minus 0.9 5.67 e to the negative 8 times, what's this, 25 plus 273 to the power of 4. Problem is, I don't know what the sign convention is, so I might just stop here, honestly, and then go to office hours or something tomorrow. Alright, regardless, I will be right back. Yeah, guys, I'm gonna have to call it early. I've got a bunch of chores I gotta do, and I'm not feeling super great. So I guess I'll see you later. What a way to end the stream. 10 minutes of be right back, followed by it swiftly ending.